Hello, hello. Time for another data demo. So this time doing sentiment analysis with spark-nlp. This is John Snow Labs spark-nlp library. And the idea is that they provide you with lots of pre-trained libraries, and from them, I'm going to do some natural language processing. So the library, according to them, according to the website, is quite popular. You can see that there's a number of other ways in which you can do NLP or natural language processing. And one of the reasons it's quite popular is it comes with lots of models. And if you look at this middle part, this is the part that I like the most. That it comes with BERT and Elmo and Glove and all the rest of it, including newer ones like Roberta and so forth, XLNET. So as research is done, the time between when the research provides a model and that it's available on this spark-nlp library is a pretty short amount of time. So today we'll be looking at classifying the text as in terms of its sentiment, and also show you about the emotion detection that they have. You can do a number of other things like entity recognition and breaking up your sentence into the structure of the sentence in terms of tokenizing and normalizing a grammar in the structure of a sentence, noun, verb phrases, and all the rest, the grammar analysis. So it does lots of stuff in this library. It's very, very useful. Here's a longer list that they have. As I mentioned again, they have a lot of embeddings which are quite useful. And one way you can find about the models that they have is you can go to their NLP Models Hub and just search in the hub and find the model that you want. And hopefully they have one that's that you can use. When you get there, you'll find something like this, XLNET, that uses the IMDb, the movie database that was trained on. The model itself is a Hugging Face model, and they point you to the link so you can go find further details about the model. They also show you how to go through a sequence here with PySpark to read some data that's in a data frame. In this case, we're going to use a document assembler, a tokenizer, so forth, and eventually transform the input to get the output, which is some sentiment analysis. The output is actually quite detailed. It's a little bit different than maybe when you've used other Spark ML library transformers and estimators. The output here has some annotations, and all of the annotations in a particular format where it annotates the type, begin, end, result, metadata, embedding. So one of the parts of the pipeline is going to analyze your document, for example, and then it's going to have an annotation type for that document analysis. Same for sentence embedding, and same for sentiment. So then to get the results out, it's a little bit trickier because you have to navigate this data structure in order to get some of the elements out that you want, but it has more information than you might normally have in a typical transformation as part of your pipeline. More information, you can go to the John Snow Labs. They have lots of interesting libraries, but the spark-nlp one is the one I'm looking at today. And they have a YouTube channel, which is quite helpful, and some demos, which are really nice. You can go to this demo site and try the model online, and also you can click on get a Colab notebook so you can run the notebook and see how it works. Just a note about this that can be confusing. I found it a bit confusing at first. These are pre-trained models, and these are neural net, TensorFlow, large models where the weights are defined by a previous analysis. That is, someone pre-trained a model on a massive data set, typically using a large cluster, by Google or someone, and they can be expensive to generate. And common usage of this sort of thing would be to first take that model and then adapt it by adding a layer to your BERT model, for example, and adapting and customizing the model for your purposes. So in this example, here you have the pre-trained model, and you notice at the right it has a certain number of labels. And then a common sort of customization or fine-tuning would be to modify some of the model weights, perhaps, and or add a layer at the end that may determine a different number of labels, typically a subset of labels. And this sort of customization is not provided with the spark-nlp. So you just get these pre-canned models and you're pretty much done. So they work great though. So the agenda here is to show how to prepare your notebook for using spark-nlp. It works same if you're setting up to deploy to a cluster using, say, Kubernetes, but I'm just going to do a notebook today. And the key is to load the library. So you're going to need a jar file, a Maven library, as well as a PySpark library, Python library. And then once you have that, then you can do something as simple as this. And this is what I recommend. Just use the pre-trained pipeline to take a data frame, particular column in the data frame, for example, and then analyze it according to the pre-trained model for sentiment or emotion or grammar if you wanted to. I'm not doing grammar today. But you can also, if you need to somehow manipulate your input data before running it through the model, you can do a pipeline, and they provide a variety of pipelines, and I'll just demonstrate one. So let's see if we can get this to work. I've got two different kinds of notebooks that I'm going to demonstrate this on, and one is going to be Colab, which I'm going to use mostly, and then I also have the Databricks, so you can download both of them from the GitHub site. So here I am on Colab, and I've got a notebook which you can download from the GitHub site. It has an introduction and some links that might be helpful, and some notes about if you have trouble with your notebook, about how to restart it and what kinds of things to look for. So one of the things is if you don't have the jar for spark-nlp working, then you'll get an error. And it's important to make sure that you not only include the Python modules, but the spark NLP jar. It won't work without it. So went ahead and run this already, but just to note, I've got a previous video on how to set up your Spark in Colab, and just a reminder that you can install the Find Spark and run it. And in this case, we are going to do a custom session, so we won't use this classic way of setting up a Spark session in the notebook. Instead, we're going to use this other method here. So first thing to note is that we're going to install the Spark NLP. And it's important that this version match the version that you're going to install from your jar. So make sure the two versions match, otherwise you'll regret it. Oh, all right, so here we go. We install our Spark NLP and we specify the version. The current one I see today is 4.2.4. So I have a listing of jars that I'm going to use when I create my Spark context. I use the prefix for John Snow Labs. I have my Spark NLP and then the version here. And the version I want to use is I'm using with Scala 12, and then of course this is the version of the Spark NLP 4.2.4. You'll note that those jars then get added to my Spark session builder, and if everything works, then I'll get my Spark session. There's a few other things you'll need to do, and if you just copy this, it'll be fine. You can see it from the documentation on Spark NLP, but these are important to add. Okay, so I've got my Spark session going. I can go ahead and add the Spark UI, which I have here. I'm going to skip over that. And then I'm ready to use my Spark NLP. So I've got my Spark NLP imported, and then the particular elements in it that I'm going to use, the pre-trained model and the annotators and base and whatever else you might import. And you can see then I print out the versions of things, and it seems to be working. Then for this simple demo, I'm going to have a comment here, and then for all the models I'm going to run next, I'm going to see what the sentiment is for that. Just a reminder, I can do everything here on Databricks, so I have the same thing on Databricks. You can see it's the same. And it gives you a reminder of how to set it up for Databricks and points you to the same information that John Snow Lab tells you how to install it for Databricks. So I just want to point out here I'm in Databricks, and I've gone to my cluster menu, and there I have my library, and I go through the process to make sure that I install the John Snow Lab NLP library and also the Python one. And just a reminder how these are done: you click on this install, click on Maven, you search packages, and you search Maven packages, and then you type in johnsnowlabs.nlp. And hopefully it should show up, and you get the right one. I want this one here. So, of course, you can do variations on it. You can read more about it, but the default one is the one I want here. And same sort of idea, if I'm doing the Python part of it, I'll type in spark-nlp equals 4.2.4, make sure it's the same. So notice again that the version is the same. Once I've got that, and I might have to restart my cluster, then I'm ready to go. And the same thing happens here in Databricks. Once I have that up, then I can go and use all this. Just a reminder that that this in Colab, we specified this serializer and so forth, and that is specified when you create your cluster when you create a cluster in Databricks. And I don't know that I can create a new cluster right now, but if I could, yeah, I would specify. I would add those descriptions here, and this is where you add it. And see another video I had about setting this up to run. But in short, let's see if I can copy it somewhere. Copy and paste these in. This Databricks, I copy and paste it in when I build my cluster. Make sure that these settings are properly set. Okay, there's that. That's Databricks, and then the rest of it is the same. So if you see my example here, and then I'm going to run a pipeline, it's the same as I have in Colab. So they're exactly the same going forward. So let's look at it in Colab just for fun. I've got my comment here. It's sort of a tricky statement for sentiment. The movie I watched today was not a good one. Was not a good one. So, you know, that'd be sort of bad, right? So now let's go ahead and see how the sentiment works. And it's easy as this. Don't think anything more other than this. You know, it's so super easy. Pre-trained pipeline. I'll select one of the pipelines. I can select the language. It does multiple languages. And then I can take that and annotate the comment. And what is the what is the comment? That was my simple text here. Okay, and then I'll look at my results and the comment column, and simple enough, it's negative. So that one worked, and that's this particular pipeline. So let's just go look at it just for interest. So I'm going to click on this and provided some links. And then you can see here the model that they have, and you can do a live demo, you know, open it in Colab. There's some even simpler way to do it here in Python, which I'm going to skip over to talk about how to work through this and the results. So this is where you get all your models from. All right, so back to just to go through a few other models. I mean, there we are. We're done with the sentiment. I'll show you with the data frame, but just that's a start. So we can do the same thing with the IMDb model, the model that's trained on this. And in this case, the same pipeline is above, but instead of analyze sentiment, it's analyze sentiment DL, use IMDb. It's deep learning, and it's going to be a little bit more. So you can look at the size of the model here when it downloads. So when you first set this up and run it, it's going to download the model, and it may take quite a bit of time. You can see the first one is 4.9 megabytes, and the second one is 935. It's quite a bit larger, and you would think being trained on this larger data set, it would be better. But it says that this sentence is positive. So in this case, it makes a mistake. It says the movie I watched today was not a good one, and that was a positive sentiment, which would be incorrect. So it's interesting that this one smaller model is better than the newer technology with this deep learning and also a larger model. So you can see here more about the sentiment analysis using this particular model. Okay, next up, GLOVE is another embedding that you can use. You can read about it by clicking on this. And of course, there's others. I'm just giving some samples and gives an example how to use it. And essentially I did the same thing here. Pre-trained model, same old style, right? GLOVE is the model we're going to pre-trained pipeline that we're going to use. And we're going to go ahead and annotate it and get out the result here. So in this case, it pulled out a little bit more information, the annotation category. It gives a positive and some information about how much positive, 99% positive and almost 0 negative. So once again, GLOVE thinks that this is a positive statement. So that's using the pre-trained pipeline. So it's a whole pipeline, and it's as simple as that, pre-trained pipeline, and pick a model and it works. Next up is if you want to do your own pipeline, which might be necessary if you wanted to transform the input data before you ran it through a model. And now let's do a little bit more than just a sentence. Let's load up a data set, for example. So data frame, and here's a data frame of some sentences. So now you can see a little bit more involved. And then let's run it through our model and see what the results are. So this was I believe this is a data set used to train some of the models. And so this particular data set has not only the text, but also the label that was provided. So this could be a labeled data set. All right, let's give it a try now with the pipeline. So we've got a document assembler, which is going to read our document and in each row of our data frame. And the row is going to be the input column is going to be text. It's going to output a document in the document column. That will be input for the next part of our pipeline, the tokenizer, and it outputs tokens in the token column. And it just goes through the normal sort of thing, a pipeline. Input token for the normalizer, output normal. And then this model takes in 2 columns of document and the normalized text and provides a resulting sentiment. And then you can use a finisher to tidy up the output, which, as you can see, has a lot of annotations in it. But if you use the finisher, it can simplify the output of the data. We'll go ahead and fit the pipeline to our data and then transform the model that we get that's been fitted to the data. We'll transform it to get our result. And here we go. Here's our text as input. We did have the label as input, but we didn't use it. It's just there to see. And then we've got the final sentiment. And wherever these two are equal, you know that the model worked correctly, and any time that they're different, of course, the model didn't work correctly. You can see the result here, what kind of data frame it is. So just by looking at result, we can see that it's a data frame. It has a text column, which is a string, a document, and it has this annotation type I mentioned before. So the document column is an annotation. So the input was text. The document column was generated by the model, and it's an annotated data type. And then thereafter, you have a few others: sentence embedding and sentiment. And if you want to print out the schema, then you can see, what it looks like as I introduced. It's a little bit complicated, but it has a similar structure for all the annotations. Annotation, the structure, annotation type, begin, end, result, metadata, etc. Okay. So now that we've supposedly trained our model, let's go ahead and look at the results. So you may recall above, when we did our pipeline, we fitted, and I sort of use that term generally, fitted the pipeline to the data and realized that it's not changing the sentiment model weights at all, but it does run the preceding steps, the tokenizer and so forth. So we get a pipeline model, and we can use that pipeline model to transform data. And we did above, and we can also do it for a sentence. So I create just a real simple data frame here with one sentence in it, just like I did before for comparison purposes. And now I can take that pipeline model and transform my example, which is here, and see that it's negative. So this model here, using this pipeline, evaluates this sentence as negative. That's the same as the very one that I started with, same model here, analyze sentiment. And you can see the result was negative. So above, it's all quite simple with one statement. Below here, we've got exactly the same result, but I have a pipeline that precedes the use of the model here. All right, what's next? All right, let's look at the details about this model. So we've got a data set that's, remember that it's a labeled data set. Here's all our text, here's our labels, and then here's what the model predicted. So let's see how well the model worked. So pull in some metrics here from sklearn and generate the metrics to see how it scored. So we apply the model above to our data, and then we'll get out some results and run it through to get a classification report and accuracy score. The accuracy is down here, and the classification report is here. If you look at it, you know, you could look at, for example, F1 score and just look at that column. And then let's compare this supposedly trained model, right, with an untrained model. So now I have a different model. Notice I have the same pipeline as above, but I don't have any data. There's nothing to be fitted. So just looking above, just to remind that this is our pipeline. So in one case here, I've trained it on some data and got a result. That's what this evaluation of this trained data is. Next up, I take the same pipeline and I fit it on nothing. There's no data there. And then I get my model, and then I'll use that model to run the same example I ran above. So, well, that's just the example. It shows the same result. And then I go ahead and also run it on the data to see how it compares the untrained model with the same data set. And if you look at the F1, again, what do we have? 0, 57, 53, compared with the other one, 0, 57, 53. You'll see they're the same. So why do I show this? I just want to remind you that this pipeline, you might be thinking that somehow it's going to update the weights in your model, and it is not. So it's not, the model is just a pre-canned model, and the only thing you get out of the pipeline is updating the input to the model, but the model itself does not change. The weights do not change. So with that said, then you might as well use these pre-trained pipelines when you can, because you're not getting really any value out of the pipeline. Now, if the pre-trained pipeline doesn't work for you, then you'll want to come up with your own pipeline, but it's going to run through the same model in either case. So that's what this little bit of code is, just to demonstrate that it's not updating the weights. It's not tailoring the given model to your case. It's not doing any transfer learning or fine-tuning. All right, that's an important point. So next up, let's just go through a few other models just to see how they would work. This one uses XLNET. Everything is pretty much the same, except for this time we're going to select a different classifier. So in one case above, we selected this classifier here, right? And pretty much everything else is going to be the same, but we just plug in a different classifier. Okay, this one is a deep learning classifier trained on the IMDb and should work pretty well. And in this case, I just wanted to show you the output, what the output looks like. And once again, it's an annotated output. So just picking out one part of it, let's pull out the document result and the sentiment and maybe some classification metadata. So that gives us our original input as text, and this classification information about the category, it's negative, the sentence, some negative and some positive, and so forth. Okay, so you can pull out the text in the class or further details, as I do in the second case. The sentiment is here and some class data. So just using some common PySpark notation to look into the data structure of a column in a data frame to pull out some of the elements. All right, next up, just going through next a few more models. There's a deep learning model for sentiment. They have it in this universal encoder. You can read about it here. It's trained on the Stanford sentiment of about 25,000 movies. And we can go ahead and run it through the pipeline, and hopefully everything works again. So same sort of idea. Okay. Next up, let's go on to another subject here. Let's go on to emotion. And if I look at my table of contents here, you can see about where we are. We should be on emotion here. So we're most of the way through this notebook. All right, so in addition to sentiment, it has some models for emotion. And we'll use this BERT sequence classifier emotion, and we'll plug it into our simple pipeline where the BERT classifier for emotion is going to be our model. And once we have that, then we get out some emotion, and we can, for this sentence, we can get out some of the metadata. Overall, it's joy, but then it has a number of annotations about sadness, surprise, and so forth. These are some elements of the emotion that it's encoded in that sentence. So, once again, maybe it's not so great. So not a good one is joy. I would, normally think that's not how I would interpret it, but okay. So another one here from Huggy Face is an example. I like you, I love you, and then what does it say? It says that this sentiment is love. So this one looks closer to being correct. Next up, another emotion, spark-nlp. Now this is their deep learning that comes with the spark-nlp. And let's see how this works. They have a universal encoder, and then followed by the deep learning model. Okay, this is the emotion model. And same sort of idea. The movie I watched today was not a good one. So sadness. So this looks to be a little bit better than the previous one, which said joy. And we can go on and give it, here just a sample data frame, just do the same sort of thing. A few sentences here as an example and see what the result is. Once again, illustrating how you can pull out of the resulting data frame some elements of this structured data to see what the result is. Okay, one more run of the same. You can find various text inputs to try. Here's another one from a notebook. This text was provided, so let's see how it works. So same model is defined above, and then let's see the results. So you can read each one. I'm so happy the news came out in time for my birthday this weekend. So this is surprise. Just wanted to show how you can pull out some elements. In this case, you might just want to pull out the result and maybe not the alternative or the other metrics involved. And this is just an illustration of how you can use typical PySpark data frame structure to combine a couple columns and explode them to new rows and then pull out the sentiment. So you can see in this case I've got a sentence and then the sentiment. So it's just a way of pulling out the information that's embedded in this data structure. All right, last up is another kind of model that the spark-nlp provides. This is a question answering model. It's T5 is what it's called, and I found that it's helpful if you have a fair amount of memory. So if I'm running in Databricks and I have a community edition, I need to restart my model at this point. So that's why in the Databricks version, scroll down, I have it set up so I can restart my cluster. Here's my motion and so forth, everything we've done. And so normally right here, I restart the notebook, and then I run my imports again. And that's because I need to have as much memory as possible, and the preceding examples typically fill up part of the memory. So here we go. Once I've set up my pipeline, I can use this. So I have a document assembler to read something, and then I'm going to use this pre-trained T5. And this is going to provide a variety of ways to analyze text. So one of the first ways to analyze text is to set it to question answer mode. So I'm going to give it some questions. So the way it works then is I'm going to run the model over some data. That's the first thing I'm going to do. So in this case, you can see this is my data, and I've got some questions. And so I'll fit it and transform it, and then I'll pull out the results. So the idea is that the T5 model already has all the answers to your questions. And that's the notion of this question answer model. So with that assumption, then you pass in some questions and it's going to answer those questions. Of course, you would customize this for your particular case, but this is the base model, the T5 model is your base model that we're going to start with. All right, so here's a few questions you can see. And I added a few from the demos. The demos, they have, oops. In the demo, all of the questions are answered properly, but I just want to illustrate that that's not always the case. So I added on here some of these ones that are not going to be answered properly, and here are the one that they typically have as their demo. So if you look at the bottom ones first, you can see it works perfect, of course, in the demos they provide. What is the capital of Germany? Most common language of India, president of Nigeria, and so forth. But then I added the ones above, and you can see that maybe it's stuck in time. Who's the president of the U.S.? Kennedy, and capital of the U.S., Washington, that looks okay. Capital of Montana, and best breed of dog, some subjective thing it doesn't know. But anyway, that's the idea, that you start off with the model and you can pass it some questions. Now, what about using it to answer some sort of general questions? So we'll start off with the context. Peter, last week was terrible. He was in an accident and broke his leg while skiing. And then we'll have some questions about that context. So this is the standard demo they give, and you can see then first you have the context and the question, and then the result. And it looks okay. He had an accident and broke his leg, and that's why his week was so bad. Same thing about a news article. So we have one about Jack Ma and so forth. And given these questions, and then the news article, we can ask some questions about it and get some results. All right, last step, we can summarize the document. So we'll set our task now not to asking questions, but summarizing a document. We'll pass in a document and then ask it to summarize. We do that by starting with our data, we fit, transform, and then we look at the results. And the results is a summary of the above text. If you want to know more about this sort of model, this T5 model, then you can, look at John Snow Labs notebooks. They've got a notebook for this, and it has a number of tasks that it works with, as you can see here. Okay, that's the demo. So in this presentation, I showed how to prepare for the use of spark-nlp, because you have to load the libraries. That's an important part of it. Not only do you have to import your PySpark module or your Python module, it's important and necessary to import the jar file from Maven. I introduced the simple idea of using a pre-trained pipeline to do sentiment and also motion analysis. This is the simplest and easiest way to do it. You can do it for a sentence, as I demonstrated, but also on a data frame. And then next I showed how to do it using an explicit pipeline. It's probably not all that valuable unless you really need to transform your data before using the model, because the model itself does not change through the training. The weights for the model remain constant. Okay, that's the demonstration. I hope it works for you.